Welcome in to Trucker Talk Radio. You're on Behind the Wheelhouse with J and J. I'm John. This is Justin. Today we've got a guest who has spent more than 4 decades sitting at the intersection of engineering and the open road. That's right, Rick Mihelic. Did I say that right?
Close enough.
Mihelic, okay, is the Director of Emerging Technologies at NACFE, the North American Council for Freight Efficiency. Before NACFE, he put in 20 years at PACCAR on aerodynamics, fuel economy, and advanced truck development, plus more than a decade on aerospace programs with Lockheed, Trident missile, Space Shuttle, life sciences, the superconducting. He was the aerodynamics lead on the Peterbilt Cummins Supertruck program. I can't wait to hear about that. For the Department of Energy, he's an SAE Buckendale and Crawford Award winner, and he runs his own shop, Mihelic. Again, he's going to correct me if I'm wrong. Vehicle consultant out of Sequim, Washington. Tough words today. When NACFE talks about where freight is headed, Rick is usually the one holding the pen. Today, we're getting into all of it. Fuel economy, aerodynamics, the messy middle, what's that? Electric and hydrogen, autonomy, AI, and what fleet should actually be paying attention to versus what's just noise. Rick, welcome to the show. We appreciate you coming on.
Absolutely.
Thank you for having me on, John. One correction, it's pronounced squim. It's spelled
Squim.
sequim, but it's pronounced squim.
Squim.
Locals will get upset with me.
This is the part of the show we like to call ReadyApp's Who's Behind the Wheel. It's something new, and it ties right into what ReadyApp does. ReadyApp is building the verified driver layer for the industry, the digital driver passport, driver verify, a verified load board, all of it. Rick spent his time proving you can't optimize what you don't measure. We'd argue the same at ReadyApp about driver identity and credentials. You can't trust what you can't verify. Every guest gets a question from our team at ReadyApp, and you spent 40 plus years measuring trucks, drag numbers, miles per gallon, real world data on what actually moves freight efficiently. So here's the question. In all that testing, what's the one thing you've learned about the driver behind the wheel that the data alone could never have told you?
Quite frankly, there's no average driver. There's no average truck. That's the one big thing everybody needs to understand. Every situation's unique, every route's unique, every load's unique, and the results that you get from the drivers can change depending on who's behind the wheel. You can get 30% difference in performance of the truck just by the driver. It makes it easy to talk about a U.S. truck or a U.S. driver. People love to do that, but everybody's different. Every truck's different. Every route's different.
Yeah, that's true. Yeah. So let's go back to the start. You came up through aerospace, right? Lockheed, NASA, correct? DoD programs. Before you ever touched a Class 8 truck, how did an engineer working on missiles and the Space Shuttle end up being obsessed with something like semi-trucks?
I actually cut my teeth on a Freightliner cab over when I was in college. They brought me in to do analysis of what was causing the noise that the driver heard when he was going down the road. And so that was a college project for me back in 1980. When I went to work for Lockheed, I actually worked for their ground support equipment first. So I was actually looking at equipment that hauled 100,000 pounds of missile around before I got into designing the other end of the missile. So I've been around the block a bit with trucks.
Yeah.
And I worked on probably the biggest truck you can imagine, the Space Shuttle. So it's always
I don't
there.
think our listeners think of the truck as or the Space Shuttle as a truck.
Yeah, it hauled a lot of stuff into space.
Hey drivers, our partners over at Zero Breeze have designed a no idle air conditioner for sleeper cabs and fleets that can pay for itself in just one summer. If you're spending up to $40 a night in fuel, it's time to stop idling and start saving. For $50 off, email sales@zerobreeze.com or text them at 945-247-1298. And don't forget to ask them about their extended warranty option. Check them out today at zerobreeze.com. I don't think a lot of just normal Americans even understand what all is hauled up to space with the space shuttle. Could you go into that a little bit?
Oh, sure. I was working on a number of different programs where they were hauling test equipment to space. So inside the back of the space shuttle was a laboratory that would fly up on certain flights. Um, and I worked with the equipment that went in that laboratory and the engineers that helped design the equipment and train the astronauts for using that laboratory. They also hauled up all of the parts of the space station over the course of a decade. They used to haul satellites up and deploy the satellites, and some of the best missions, they went up and serviced satellites in space. So they would haul up equipment to help service the satellite while it was in orbit. You can imagine having a toolbox with you in space. It's a lot
Yeah.
different in zero
Yeah.
gravity, having tools you have to keep track of.
Right. So
Yeah,
what year was this that you were working on the space shuttle?
I was working there from 86 through 92.
Okay, so right around the time of the Challenger, right?
Yeah, I came in right after Challenger, so I got to enjoy all the paperwork that went with making things
I'm
safer and
sure.
better.
I
Jeez.
bet. So with the space shuttles and everything, is there any comparison to what they go through, of aerospace to the logistics side with trucking?
With the space shuttle, it's all about weight, right? You have to pay a lot to get something into space, just like you have to worry about how much your truck freight is going to cost to move. So fuel economy is all about weight with the space shuttle. And there's a parallel there with trucking. Weight's always been a big concern. The tare weight of the vehicle is always a big concern for fleets.
You were the aerodynamics lead on Supertruck for the Department of Energy, correct?
For the Peterbilt Cummins version of it, yes.
So for folks who have never heard of it, what was the Supertruck actually trying to prove?
So they in 2009, the government wanted to show that efficiency was achievable in diesel trucks. And they set this, what they thought was an aggressive goal of improving the freight ton efficiency of the trucks by more than 50%. And four different teams were given some money, and they had to bring their own money to the table. There was a partnership there where you had to have your own skin in the game. These four teams included a partnership between Peterbilt and Cummins. There was Freightliner had a team, Volvo had a team, International had a team. Back then it was Navistar, and they each independently developed trucks that would exceed 50% improvement. So we came in, we were the first ones to meet the objective, and our first vehicle got 10.7 miles per gallon when the industry was seeing, 6 miles per gallon.
Right.
And we saved a lot of weight on the truck so we could put more freight in the truck. So we were in the 75% to 100% improvement in freight ton efficiency with available technology. We weren't doing anything that was, 50 years out. We were doing things that you could do today.
Something I would like to get your opinion on, because when you talk about like truck technology and what it is today, and so many drivers who have been in this for a long time, their whole lives, they always say the trucks today, the newer trucks just aren't built like they used to. They don't last like they used to. They've got all these emissions on them. What do you say to those drivers who are just frustrated with all this, with all these problems that come up, the length of time they spend in the shop?
Yeah, uptime has always been a big issue with any vehicle. But if you look back at the 1980s when I first started in this, you didn't have electronic systems at all. It was just basic mechanical things that were running the engines. They failed too. We all have kind of rose-colored glasses about how
That's
great those
true.
vehicles were back in the
True.
70s and 80s, but quite frankly, they weren't all that great. I had a friend who's got his '66 Buick from when he was in high school, and I've driven that a couple times, and there were no power steering, no
That's I
power
was just gonna
brakes.
raise. I did the
Windows didn't
same
roll.
thing with
No,
my buddy's
no.
Volkswagen Bug. He's got a Volkswagen Bug from back when we were in high school. He still got it, and I've driven it, and it's hard to drive, and it's extremely uncomfortable.
Yeah, ergonomics was nothing back in those days. So if you had a seat, you were lucky, right?
Mhm.
Your passenger probably had an orange crate that he was sitting on. Things have changed. Along with that, complexity has increased. You've had a lot of digital things added to the truck. We all want those things. We seem to like having digital radios and digital music and tracking systems for knowing where things are all the time. And there's a cost to that. It adds complexity, it adds failure points, but 97% uptime is still achievable for a lot of these vehicles, even though they've got all that complexity. And with over-the-air updates, the at least for the things that are software related, fixing them can be done without having to go into a garage now for a lot of things.
What's the single advancement, the one thing, or maybe it's a couple things that really you feel like have delivered the biggest real world impact on efficiency?
Well, if you look at the trucks from about 2008 on, there was a huge emphasis on making them more fuel efficient. And there were a lot of reasons for that. But the truck in 2008 that we used as a baseline in the Supertruck program was getting about 6.4 miles per gallon. And it was a relatively good truck aerodynamically. But over the last 20 years, you've seen huge investment in making them much, much better. And so the trucks today that you can buy, your 2027 model year trucks are able to get over 10 miles per gallon in on-highway operations in real-world conditions with real loads. We do a run-on less event every 2 years, and we've been able to document over the last several years that it's very easy for the new model trucks, properly driven, to achieve over 10 miles per gallon. And that's huge today. If you look at the price of fuel,
You said if they're properly driven. We have a lot of
yes.
drivers who listen on this truck. Would you explain to them what that means?
Yeah, I work with a number of drivers that they're I guess you could call them owner operators, but they understand their bottom line and they understand that
Mhm.
fuel is expensive, and so
Yeah.
they go out of their way to you might call it hypermiling. They really understand what uses fuel. So one of the guys that we deal with, he drives at night so that he doesn't hit congestion inside of uh, beltways like Atlanta or Dallas or places like that. So he's intentionally missing the worst traffic.
Okay. And
They try and
that's what you mean by hypermiling?
yeah, they're doing everything they can to maximize their fuel economy. So one of the drivers we worked with, a female driver up in Michigan, she talked to it as always driving like you're on ice. So you give yourself room between you and the vehicle in front of you to slow down gently. No
Mhm.
radical shit, slowing down. No applying brakes rapidly. No jackrabbit starts, and all of that turns into better fuel economy.
I hope my wife's listening. She's really hard on the brakes.
Wait a minute now.
Yeah.
You always say she's the one driving, so you don't want her to put you in under there driving because you don't like driving. So you so I want to ask you with all the technology that has come in to the industry in say the last 10 years, what technology has provided the fastest return on investment for a truck owner or a fleet, would you think?
Yeah, the two easy investments are to buy a new truck and then make sure that you spec it with low rolling resistance tires. So with the new truck, you get the most modern system designed aerodynamics. So it's designed to give you the best aerodynamics possible. And then make sure that you put low rolling resistance tires on that truck. Those are the two biggest contributors to efficiency improvements that you can do. After that, it's training your drivers to actually care about fuel economy. As I said, a bad driver can really mess up your averages. I dealt with one fleet that had a training program where they kept track of everybody's fuel economy, but they really only cared about the bottom 10% performers. And what they did was they focused on them. If they could get them to improve, the whole average of the fleet greatly improved. And then when those bottom 10% got better, there was a new bottom 10% that took their place. And so they focused on them. And over time, their fleet averages went up tremendously by doing that.
So drivers notice these modern trucks look completely different. All the smooth lines and the fairings. How much of that look is purely aerodynamics doing its job, and how much of it is just to look cool?
Yeah, about 30 years ago, you would have seen things getting put on trucks that looked aerodynamic but weren't necessarily. I
Hmm.
had a friend of mine called it aerodynamics. It looks aerodynamic, but there wasn't a lot of evaluation or testing that went into that. The trucks that you see today, they had to make fuel economy improvements in the aerodynamics to offset other things that were going against the fuel economy. So you added more and more equipment over the last 20 years for emission systems and all these extra features that people are looking for in their trucks, and added weight for things like all of your creature comforts that you want in your truck. All of that had to be offset by something. And so the aerodynamics you see today on the truck, they've all earned their right to be on the truck because they do something positive for the fuel
Mm.
economy. You don't see all the chrome and polish. My chief engineer used to call it dipping the truck in chrome. You don't see a lot of that on the new trucks, and it's because most of the exterior is already designed for you. You don't get to add 15-inch air cleaners and side pipes and things like that because the truck isn't designed for that. It's designed for performance.
Well, speaking of performance and aerodynamic, so we have these trailers, especially the dry vans. They've got the underskirting now, and they've got, I don't know what you call what's on the back end of the door. It's like a parachute almost that just shoots
Yep.
out. Does that help a lot, or is it? Because I know a lot of drivers don't like the skirting because it really messes them up where how they can turn into places, different things. Now I'll be honest, I don't know a lot about the back end, what it does other than just kind of opens up. But does that really seem to help the numbers as well?
Yeah, if you look at what we did on Supertruck, we designed a tractor and a trailer as a complete aerodynamic system. So what we did in looking at it as a system, we maximized the performance of the whole vehicle. And we added skirts, we added trailer tails to it, the back end,
Mhm.
and we also closed the gap between the tractor and the trailer. And the combination of all those things is how we got above 10 miles per gallon. The best thing you can do is put the skirt on, and then the next best thing you can do is put the tail on. Um, there's a lot of problems with the tail because it's an area that's hard for the driver to see. And a lot of the systems that were developed in the last decade require the driver to open and close them. And anytime you have to ask the driver to do something, half the time they're not going to do it, right? So,
That's the truth.
You can tell he has experience in trucking.
Explain what those tails are meant to do for drivers and listeners that don't know.
yeah, if you take a look at your race cars, your stock cars, there's the back end of the vehicle has been shaped to reduce the space of air that's behind the vehicle. So you have air flowing over the back of the vehicle. You want it to get back into being normal air very quickly. So with a trailer, you're looking at this big cube plowing down the road, and it's got a huge amount of vacuum behind it, a lot of swirling air in the back of it. So what that trailer tail does is it smooths the airflow as quickly as possible, so it gets back to being normal air behind the tractor. I did testing with several trucks on the road. Other people have done testing on the road. The turbulent region behind the vehicle can extend for a mile or more.
Wow.
If you think about when you're in an aircraft and coming into landing, you're following another airplane. There's a reason the FAA requires a mile or 2 miles of separation distance between those vehicles, is because the first airplane really disturbs the air. The same is true on the highway. That tractor has a lot of impact on the air, and the better you can smooth the back end of the vehicle, the quicker that air gets back to normal, and that reduces drag.
Is that kind of like I'm a big movie guy, so is it like Top Gun? The first one when
Yes.
when the plane goes down, he says, you're in his jet loss." Is that what that is?
Yep. Yeah, exactly. The same thing.
Okay, so that's why those planes shouldn't be so close to one another.
Yeah, if you look at racing in particular, car racing or bicycle racing, drafting is a big deal, right? It's because you're putting two vehicles closer together than they should be, and what happens there is that it reduces the overall drag for both of them. So in stock cars, you always hear that the guy behind is pushing the guy in front. They're both doing better. The guy behind's doing much better, but the guy in front is helped along too.
I'm curious. I just want to take a step back for a minute because this is all it's really cool stuff. I mean, aerodynamics, working on the Space Shuttle, NASA, Department of Energy. I mean, like all this stuff is super cool. So go back to your childhood a little bit. Like, where'd you grow up? Like, how did you get into this? Where'd you go to college? Like, tell our listeners.
Sure. I grew up in Oregon, Eugene, and the Oregon Ducks, right? So
yeah, Nike.
Nike, that's it.
When I was growing up in the '60s, lumbering was everything, right? So everywhere you went, you saw trucks hauling. It was just a part of your daily life. If you went out on vacation somewhere, you were passed by trucks hauling really big trees. Well, the trees have gotten smaller, but there's still a lot of trucks out there hauling trees. So that was kind of where I got into liking trucks. I went to school at the University of Portland as a mechanical engineering student, and Lockheed hired me out of that to work on the Trident program, the Trident submarine program. And I was working on missiles there, but I initially got hired into the ground support equipment group, which is all the equipment that moves the missiles around. So on land, so trailers and tractors and things that take them from being horizontal to vertical. I was working with all of that heavy duty equipment. And then somebody spotted me and moved me into the front end of the vehicle, working on the part that delivers the warhead. And so I got interested in space, and across the runway from where I was working was the NASA Space Shuttle program that trained all the astronauts and provided all the life sciences hardware for the Space Shuttle program. And Lockheed had a support contract for that. So I moved over there and got to work on on the Space Shuttle for several years. That was interesting, but I wanted to get back into other things. And so the national laboratory that was being set up in Dallas, in Waxahachie, actually, hired me in to work on designing equipment to move really big magnets around. These were put into 50-foot oil pipes. The starting point for these magnets was an oil pipe, and you had to have equipment that moved this stuff around from facility to facility so they could install it underground in a big 50-mile diameter tunnel that was going on.
And what were they using those magnets for?
It was a physics activity called the Super Collider. There's one in CERN in between France and Switzerland, where it's an underground ring, and they accelerate particles to near the speed of light and crash them into each other so they can see what comes out of that. You get to see things that only God has seen before. Some of the particles are called God particles because they only existed in brief moments when the universe was created. The whole system uses superconducting magnets that operate at 4 degrees Kelvin, really, really cold in a vacuum. And they accelerate these things with the magnets in a big circle, a big 50-mile diameter circle, in opposite directions, and run them into each other in these collider halls that were big instruments about the size of basically the stadium in Dallas that the Cowboys play in.
Wow.
That's one instrument was that big. They would run these particles together and see what happens.
It'd just be like mass explosions, or?
Yeah, essentially it's a controlled catastrophe. The inside of a giant measurement instrument. If you think about a CAT scan, when you're inside one of those, that's a superconducting magnet.
Yeah.
So this is just one that's huge. Like I said, it's 50-mile diameter ring. I think they had 10 different tunnel boring machines working in different directions, trying to build this tunnel when I was working there in the 90s. And then the government shut the program down midway through, and all the research went to CERN in Switzerland. And they finished a similar system there.
Okay, so they're no longer doing this testing?
Well, they're doing it in Europe
Okay.
on a slightly smaller diameter ring of magnets that are underground.
So I've got to ask you, your history of what you have been a part of is pretty astounding. I don't know if I've ever spoken with somebody that's done so many major projects with major companies as you had. I mean, you've done what, submarines, to missiles, to shuttles, to that magnet, to Supertruck. What is the one thing that you have done that you're most proud of being a part of?
Clearly, it was the Supertruck program. We had a very small team and a small amount of money. And, it was kind of out of the view of management. We were allowed to basically do what we wanted to do to show what you could possibly bring to the production world. And because we were a small program, we did some pretty amazing things, doubling the fuel economy of a vehicle, in 2 years using available technology. That getting the chance to do that is pretty rare. As soon as we were successful, there were all sorts of people who wanted to take credit for it, but ultimately our team was pretty small. 10 people or less probably did the majority of the work on the Supertruck program. That's a whole new tractor and a whole new trailer, and we built 3 of them over the course of 5 years, and did. We had a whole test program. We had to figure out how to measure things down below 0.5% accuracy. So we eventually got down to 0.1% accuracy on fuel economy measurement, which is unheard of on testing things. So there was a lot we did, And that's the one I'm really most proud of.
So let me ask you then. So how much room do you feel like is left on the table? Are we near the ceiling on diesel efficiency, or is there still serious savings you feel like could be found?
It really comes down to looking at how big of a picture are you analyzing. So back in the late 50s, the guys who developed a roof fairing for a day cab, they pushed the envelope tremendously on fuel economy. They probably got a 10% improvement in fuel economy by adding a roof fairing to a day cab. But they were only looking at adding a roof fairing to an existing truck. What I got to do was design a tractor and trailer as a complete unit. But if you take a look at a tractor and trailer followed by another tractor and trailer as a complete system, there's room to make that even better.
Like platooning, right? Walmart did
Platooning or
some of that.
drafting, or you look at these autonomous vehicles. An autonomous vehicle is essentially two vehicles following each other on the road. And the shorter you make the distance between them, the better their fuel economy. So you can look at that. You can also look at long combination vehicles. So LCVs are another big opportunity here. In the Northwest, you see a lot of triples running on Interstate 5, or triples running into Idaho. Nevada has triples. You can find triples everywhere on the West Coast. That's another way where you're increasing the amount of freight you're carrying per tractor. And so you can get better fuel economy overall versus running two trucks. You can get better fuel economy with one truck. So there's lots of other opportunities out there. You just have to expand how you define the system that you're trying to improve. And we're getting to the point now with all the autonomous vehicle discussions that you can talk about 2 or 3 vehicles doing better than 3 vehicles all by themselves, and get better fuel efficiency. So there's not really a roof to improvement with a diesel. Supertruck 2, the international guys got 17 miles per gallon with a diesel powered truck. It had a lot of electrification with it, but it was essentially a diesel powered truck, and they got over 17 miles per gallon. But to your first point way back when, you were talking about adding complexity. To get that 17 miles per gallon, it got pretty complex. The vehicle's got a lot of systems on it. So another way to look at this is to look at the truck has maybe a battery electric powertrain in it. So you look at the Tesla Semi, it's getting effectively better than 18 or 19 miles per gallon using an electric powertrain. And since most of the vehicles, more than 75% of the vehicles in the US run less than 500 miles per day, that truck has the possibility of jumping, 6-7 miles per gallon over your existing diesels that are coming out today. And that's only going to get better. That truck's only going to get better over time.
Okay. So you brought it up, we were going to get into it anyway, but autonomous vehicles, where do you feel, Justin and I both have our own opinions on it, and and there's a lot of stuff in between there. Nobody really knows how this is going to play out. From the technology side, where do you think that we are? How long do you think that we are away from having they're already running in the Permian Basin. They're already running up north. They're already running in spots. Do you think we'll ever be fully autonomous? Do you think there'll always be a safety driver? What's your opinion on it?
I think there's a large group of people out there that don't want to drive, and they don't want people driving. And so, ultimately the technology has made this possible. How long it takes to become a significant number of vehicles on the road, even I've done a lot of looking at numbers, and there's 2.8 million tractors in the United States and maybe 8.8 million straight trucks in the United States. We only build in a good year 250 to maybe 350,000 tractors.
That's a good point.
right? So it will take 15, 20 years, even if you started today making everything an autonomous vehicle, it would take 15, 20 years to replace everything in the industry.
Well, and then by then, isn't it even outdated? Because we're
Yes.
looking at like autonomous trucks right now, like with Kodiak and there's what's the Aurora. There's some
Aurora.
other ones out there, but
Yep.
now we're starting to see where they don't even need the cab. It's the trailers that
Yes.
are autonomous. So they've taken too long to get to market, and when it really comes time, are they even going to be relevant?
Yeah. You're going to see a lot of learning over the next decade. Um, there's going to be, if you look at your cell phones from 2007 when the Apple iPhone was introduced,
Mm.
you can't run anything on that phone today, right? And so every one of these trucks that comes out is going to have that learning curve, and within a 2, 3, 5 years, it's going to be obsolete. All right, it's going to be hard to update it to the latest, greatest information, and there's just going to be a lot of learning curve on that, I think, over the next decade. But in the meantime, it's going to roll out because there are business cases where it will make sense.
Mm.
And it's a technology, like I said, there is a large group of people out there who don't want people driving.
Mm.
And you see that with the autonomous cars, with the taxis. You see that with this love affair that people have with taking their hands off the wheels. There's just a big urge out there to take the human out from behind the wheel. So it's going to happen. Um, there's going to be lawsuits and accidents and learning curves and recalls, and it's going to be messy. But ultimately, 50 years from now, majority of the trucks might be AVs.
Right.
Yeah, I'd seen where Volvo announced that by the first quarter of 27, they're going to have X amount of trucks out, and then they're going to completely try to roll with it in 2028. So I'm interested to see how that happens. And then I seen, can't remember exactly who it was with Knight Swift. He was on a podcast the other day and said they did a year pilot study with, and he wouldn't name the company, and they had a couple trucks in their fleet and said it was the greatest thing driving straight down interstate. But as soon as it got off interstate,
Yep.
it was a complete disaster. And I can see that because, it's one thing to turn the truck, but if you ain't got cameras back there that can make it read fast enough to know they got to get that trailer in a certain position to even make a sweeping turn. And then to your point about the lawsuits, that's probably one of my bigger concerns is what happens when the first fatality happens? How does the world react? I mean, I know how they react now when it's a driver, but they have a driver to blame. Who they don't have anybody but a company to blame. And of course, companies usually just get a slap on the back for anything they do, and then it moves on. So I'm curious to how that gets affected.
Yeah, the phrase I like to use is they're designing the airplane while they're flying it. So we got a lot of regulations that are in process. We've got a lot of technology that's in process. The real world has only seen a few hundred of these trucks. We got a long way to go on the learning curve.
Since you're so familiar with the trucks, and I seen this, it just came to mind. Yeah, I believe it was Pepsi. They have allotted a lot of money to autonomous, but they're not going semis. They're going to the delivery trucks, the modified box trucks that they have for their drinks. Why don't we see that more? I know that's not what everybody wants because they can't haul as much, but maybe you start there, and like Jon just said, okay, you get through a 10-year cycle of advancement, and then you put it all back into the bigger semi, which is the ultimate goal.
Yeah, the cost savings from an AV vehicle, it comes from replacing the driver with a computer. And it's an expensive thing to go do. So you want to get a lot of miles out of the vehicle to pay it off. So you want to run it 20 hours a day or more to help pay it off quickly. Medium duty trucks only get 15, 20,000 miles a year. And so it's a challenging thing, and the driver's less expensive in the medium duty than he is on you need a better trained driver on a Class 8 truck. and it's more expensive. So the math isn't really there to help them out as much, but
Makes sense.
it does facilitate some of the math to put them into medium duty.
This is the term the NACFE has made famous. For anyone who hasn't heard of it, explain the messy middle.
Sure. In 2016, we started looking at what technology could do with vehicles, and we got into more and more powertrains since 2016. So the choice fleets have now is like a Chinese lunch menu. You've got hydrogen fuel cell, you've got renewable natural gas and normal natural gas, you've got diesel and renewable diesel and biodiesel, and you've got various forms of electric vehicles. You really have way too many choices now. And that's what we call the messy middle. Each one of those choices is optimized best for a particular duty cycle. So they're kind of purpose built for different uses. And none of them are all that great at doing them all. Even a traditional diesel truck, you see this often with drayage. You go to a port and you'll see a lot of sleeper trucks hauling drayage. They're only doing 100 miles or less a day, but they've got a sleeper because that was the used truck they bought.
Right.
Right? Over half the trucks at a drayage yard are probably sleepers, and it's not the right truck for it, but it's kind of the Swiss Army knife of vehicles. So that's what the messy middle is. And we're looking at the next 10, 20 years, having all these different alternatives competing against each other, and each of them being better for particular use. And so fleets are going to have mixtures of vehicles in their fleets to do different things. And eventually, 20, 30, 40 years from now, it'll all come back together again. It'll probably be battery electric and possibly hydrogen fuel cells. But in the meantime, we're going to have all these alternatives for years to come.
Well, and you make a good point. There is a lot of choices. And the one thing that we go back to a lot talking on the show is you like electric. That's probably going to win out a lot. But the problem is infrastructure. We have no infrastructure in America, and we are a country. I've been in Asia. They think completely different than we do in America. We don't look 20 years in the future. We're looking past last week, trying to figure out how to catch up. And just like with electric cars, we don't have a grid for that. So we sure don't have a grid for a couple million trucks to go to the Loves or a pilot and plug in, and the whole world goes black. Do you see maybe at some point we change that philosophy? Because, we've seen, countries put electrification in the roads where when the trucks are driving, they can recharge, that we have more, electric, plug-ins for even cars, much less trucks. Do you see where we finally catch up with all that as a country?
Yeah, I think we're already in that process. If you look at all the growth in data centers, they require a lot more energy than any of the trucks will ever require. So the grid is having to build itself out to support all these data centers. And I've kind of been surprised there isn't more complaints or arguments about the grid not being ready for them. They're getting built out. I saw this one facility in Hermiston that it's right next to a Walmart DC. And this data center is as big as the Walmart DC that's out there. And they built it in under 3 years, including bringing in a power station and getting power to it. It's phenomenal how quick you can make something happen if you've got money behind you, right? But, the trucking side of it is building out. You're seeing corridors being built across the Southwest with basically truck stops that are for electric vehicles. And there's 10 or 15 companies building those out across the Southwest. We had one truck that went from Laredo, Texas, all the way to Sacramento, charging at Walmarts on the way. That was a Class 8 truck. And it was hauling a regular load, and they just pulled up to a Walmart late at night and charged overnight and went on their way the next day, right? So it's feasible to do that stuff today, and it's just going to get better. Eventually, you're going to have way too many gas stations that serve electricity, like you had with gas stations back in the 60s. There were too many built, and they started closing down when they built the freeways out because they were in the
Right.
wrong place at the wrong time. You're going to
Right.
see that with electrification too, but yeah, you're going to have more than enough ability to support these vehicles at the rate that they get built, because you're not going to see 2.8 million of them tomorrow. You're
Right.
going to
That
see
is
100,000 a year by 2035 maybe, right? So it's going to take a while for these trucks to be everywhere all the time.
that's a good way to really look at it. That if you're a truck driver and you're worried about your job, you've still got a good while before you really have to worry about it.
Yeah, truck drivers and technicians in particular are going to have jobs for a long time. They may change a little bit over time, but particularly technicians are always going to be needed. Even the AVs, or especially the AVs, are going to
Right.
need technicians.
Yeah. Just hopefully they don't stop in the middle of the road
Yeah.
while hauling a load. That would not be good.
No.
Well, if you could change one thing about trucking tomorrow, what would that be?
Better truth in advertising would be great. My entire career, I've been fighting marketing hype and opinions, and the data is out there. So quit using, over claiming on things, and quit using your opinion to make decisions. Use facts. The numbers are there. You don't need to guess anymore. You don't need to roll the dice and hope for the best. Just use the data that's there and make decisions.
Awesome. Great advice. Well, you want to give a plug for NACFE, and where can people find you?
Yeah, we have two websites. The main website is nacfe.org. That's where you'll find all our reports. Everything is free on our site. And the other one is runonless.com. That is the site that's devoted to our biannual run on technology. We've done 5 of them so far. The next one's in 2027, and we don't know yet what we're doing there. But it'll be cutting edge technology that's available in production, and we'll show the world what's possible with the newest, greatest technologies.
Well, thanks for coming on, Rick. Justin, you want to close us out?
Yeah, we appreciate everybody watching today. Of course, we want to thank our sponsors, Gray Cross and ReadyApp. Go check them out, graycross.org and ready-app.com. Share, like, follow, help us spread the word. Check us out, anytime on iHeart, Spotify, TikTok, Facebook, you name it. We're on there, LinkedIn. So go check us out, and we appreciate y'all keeping a listener for us.
Yeah, the guests keep getting better, more interesting, and Rick, you're a good one. We really appreciate it. It's been very interesting. So thanks for the great conversation.
Well, thank you.
Today's episode is sponsored by Gray Cross. Every day, professional drivers make sacrifices that most people never see. Long hours, missed holidays, time away from family, and the responsibility of keeping America's supply chain moving. Gray Cross was created to support those drivers and their families when life takes an unexpected turn. By providing assistance, resources, and support during the difficult times, Gray Cross helps strengthen the trucking community one family at a time. Because behind every truck is a driver. Behind every driver is a family counting on them. If you'd like to support the mission, visit graycross.org to learn more. Donations are always appreciated, but simply sharing their message with others in the industry can make a tremendous difference. Gray Cross, supporting the people who keep America moving. Today's episode is brought to you by ReadyApp. Trust is the one most valuable asset in transportation. That's why ReadyApp created Driver Verify. Driver Verify helps carriers, brokers, and transportation companies gain greater confidence through verified driver identities, professional credentials, work history, and onboarding visibility. Drivers can securely maintain CDL information, endorsements, certifications, and employment records all in one professional profile. As fraud continues to impact the transportation industry, verification has never been more important. ReadyApp, verified drivers, trusted freight. Go check them out at ready-app.com.